Hi, this is Dinesh Kumar and you are watching Oracle videos. In today's training video, we are discussing about indexes. What is an index? See, first, index is also one of the database object. Index is also one of the database object. What is the use of index? Why we have to create index? Without index, what is the disadvantage? With index, what is the advantage? Let us see. Suppose you have a data. Salary column is there, and here we are having some salaries: 9,000, 7,000, 10,000, 1,200, 3,000, 9,000, 1,000, and again 7,000, 10,000. These are the salaries. If you want to fetch the salaries based on a condition, then we will write a query like this. What is the query? Select salary, whatever the thing you want to select, that's your wish, from EMP, where salary less than 7,000. Salary less than 7,000. Then what is happening? Internally, the complete salary column values will be scanned, and each value in the salary column is verified against this condition. Each salary from the table should be verified against the condition. Suppose here how many number of salaries are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 salaries are there. 9 salaries are checked against this condition. Suppose if there are 90,000 employees are there, then 90,000 salaries should be verified against the condition in the query. So frequently, if you are selecting salaries based on condition, again frequently if you are selecting the salary or whatever the data from the table based on condition specified on salary column, in such case each time it has to verify all salaries. So it will decrease the performance of the query. Why? Because each time it has to verify all values in the salary column. Okay, how can I decrease this? How can I decrease the number of verifications? How can I reduce the number of verifications? Yeah, by creating index on this column. Remember, if you are frequently verifying condition on this column, then it is better to create index on that column. Again, in any table, on any column, frequently you are verifying conditions and frequently you are accessing data from the table. So on which column you are going to specify conditions, then it is better to create index on that column. Let us assume here I have created index on salary column. This is indexed column. Okay. This is also known as a key column. Based on which column you are verifying data, that is called as key column. Index maintains ordered data. Index maintains ordered data. Remember that. By default, this order is ascending ordered data. Ascending ordered data. Remember that. It is the default nature of index. Okay. Now, here what are the salaries? In this, what is the least salary? 1,200. Here, 7th value, 1,000 is there. So 7 here value 1000. Next, highest value, fourth value, 1200. Next value, 7000. 3000 is there. Yeah, take it. Okay, 3000. Next value, 7000. It's a second value, 7000. And again 7000 you are having here. Eighth value is also 7000. Next highest value, 9000. From the first record, 9000. And again 9000 is there. From the sixth record, 9000. And from third record, 10,000. Okay, 10,000. And from last record, 10,000. So if you create index on this column, internally index will maintain the data like this. The data is in order, ascending ordered data. By default it will maintain ascending ordered data. Here, along with ordered values, it will maintain address of each value. It will maintain address of each value from which record the value it is maintaining. Suppose 1000 is there. 1000 you are taking from which record? 7th record. So 7th record address should be there. That address here it will maintain. Let us assume temporarily the address is 7. Okay, and so index is having two parts here. What are they? This is called as address part. Address part. And this is known as data part. This is known as data part. Remember that. Okay. Now, if you create index on the column, then the data should be maintained in this way. Now, execute the same query. Let me write same query. After index, I am selecting same data. Select salary from EMP. Select salary from EMP. Where? What is the condition? Salary less than 7,000. Here 9 verifications, 9 values are checking here. Here it will start. Whenever you are creating index on that column, immediately control goes to index, not from the table. Okay, the control goes to index and verify this condition in the index. Verify the condition in index. Okay, here see what are the values satisfied. 1, 2, 3. So here the condition was failed. At fourth value means in the index it is fourth value. Condition was failed. Whenever the condition was failed, it will stop the comparison. It will stop condition verification. Why? Because even it will continue its verification, there is no use. Why? Because index is already maintaining ordered data. Index is already maintaining ordered data. So there is no more chance for the condition becoming as true. That's why it will stop. Okay, how many number of verifications it made here? 4 comparisons only. For the 4 comparisons you will get the values 1000, 1200, 3000. Here also you are getting same output. There is no change in the output. 1000, 1200 and 3000. So I think you understood what is the difference before index creation, after index creation. Yeah, let us see. Again I am repeating, whenever you are executing a query based on condition on a specified on a column, then first it will verify the table existency. Next it will verify the column is valid or not. If the column is valid, table is existed, then the control goes to the values. It goes to the particular column and it will start the verification of the condition. Okay, so generally all values in the column should be verified. Generally, all values in the column should be verified. But if you create an index, it will reduce number of comparisons. How it is reducing number of comparisons? Because of the data in the index is ordered data. So whenever the condition was failed, it will stop the comparison. It will stop the comparison. It will reduce the number of comparisons it is making, or it is reducing the number of times the condition is verifying. So definitely it should be fast than normal table data. Okay, and remember, before index creation, this is the part. After index creation, this is the part. In both the cases, before index creation, you are selecting data from the table, and after index creation, you are selecting data from the table. But internally, the performance will be increased because in the index, number of verifications are less. But don't try to select data from the index. See, view is there. View, after creating view, after view was created, I can select the data from view. But index, don't try to select the data from index. It's not valid. Remember that. Is it clear, all of you? Then say here, it is stopping at 4th comparison. So remaining comparison times is saved. Now let me explain about index. Index is also a two-dimensional object, just like a table. Index is also a two-dimensional object, just like a table. What it will do internally? Index maintaining column data in ascending order. Index maintaining column data in ascending order. Okay. So along with the data, it is also maintaining address part. So this address part is called as row ID, record ID. So what is row ID? Row ID is a virtual column. We can say it is a pseudo column. What it is? It is a pseudo column. What it contains? Physical address of each record. It contains physical address of each record. Physical address of each record. Remember this. Based on this only, the values are fetching from the tables. Remember. Again I am repeating, index is a database object. Index is a database object. How it look like? It is a two-dimensional table. It look like a two-dimensional table. So how many number of parts are there? In index we have two parts. What are they? Row ID and after that data. Row ID part and data part. So by default data is in which stage? Ordered stage. By default data is in ordered data, ordered format, ordered form, anything. Right? What is the advantage of index? What is the advantage of index? Index is decreasing number of verifications. It is decreasing number of value verifications or number of times the condition checking. So that automatically it is reducing the search time. It is reducing the search time for the required data. So that's why internally index will play a key role. Why? Because it is fasting. It is as much as fast you can get the data if you maintain index. Clear? Table data generally it's a random ordered data. You cannot say table data is ordered data. So in online so many transactions are going on. The transactions will be randomly inserted into the table. Remember. But index should maintain, suppose, see, index is maintaining ordered data. Let us assume after some time one record is inserted with the salary 5,000. With the salary 5,000. So in the table 5,000 will be inserted randomly. But in the index 5,000 should be maintained above 7,000, below 3,000. Remember that. Clear? Yeah. This is what about index. Now let me explain about what is row ID. What is row ID? Row ID is the address of each record. So row ID is a combination of three components. Under row ID you are having three components. What are they? File number, which is called as table number, and then data block number. Next is data block number. So data block number, and next one is record number. Next one is record number. See, what are the parts of a database? Generally, within the database, there is a storage space for Oracle. There is a storage space for Oracle. Okay, in this database, you have two types of data. One is data dictionary, which contains structures of database objects. Remember, so data dictionary, and what is the next part? Actual data. So data dictionary contains metadata. Data dictionary contains metadata. First one, simple index. First one is called as simple index. What is the meaning of simple index? See, index you are creating on a column. Okay, if you are creating index on single column, that is called as a simple index. If you are creating index on single column, that is called as a simple index. What is the example for this? I want to create an index on salary column. Index on salary column. Why? Because I want to verify salary and then I want to fetch the data. In that case, create index on salary column. So how to create index? Index is a database object, so you should use create. Create index, index name idx underscore sal on, within the parenthesis, on which table you are selecting, you are creating index on EMP table. Okay, on EMP table and on salary column I am creating index. From this moment onwards, if you select the data from EMP table based on salary condition, based on a condition specified on salary column, then the search will be done under index, not in the table. For the required data, the condition should be verified in index, not in the table. Remember that point. Next, this is called as simple index. What is the next one? Composite index. What is composite index? If you create an index based on multiple columns, from the same table I am creating index based on multiple columns. In such a case, the index is called as composite index. Again I am repeating, I am creating index on product ID or otherwise product manufacturing date and company ID. Company ID is a foreign key in product details table. I am creating on an index on manufacturing date, date wise, and from the companies. Okay, so if you create an index based on multiple columns, that is called as composite index. The example is create index, index name idx underscore, you are creating index on manufacturing date and also company ID. So why? Because frequently either I will specify condition on manufacturing date and also I will specify condition on company ID. On both columns I am going to specify condition, and based on that condition I want to fetch the data from the table. Based on that conditions I want to fetch the data from the table. In that case, create index on multiple columns. On what is the table name? Product details table. Within the parenthesis, what are the columns? Manufacturing date, comma, company ID or company code. That depends on your table column. Right. Now, what is the next type of index? See, next index is called as unique index. Unique index. In this, so you can create this unique index on any unique column only. Remember this point. You can create this unique index on any unique column only. So if your column having duplicate values, you are unable to create unique index. The column should contain only unique values. In that case, you can create unique index. Yeah. How do I create unique index? Create unique index, use the keyword unique and specify the index name idx underscore, and I am creating on commission column. So here commission is not having any duplicates. Okay, let me generalize this. So here I am creating an index on mobile number column. Mobile number should be unique for each customer. Yeah. And on what is the table name? Customer details. And what is the column name? Mobile. So it is a mobile number column. On the mobile number column, you are creating unique index. Next one. Reverse index. So what is this reverse index? Yeah. If you want to search data, frequently I am looking for highest value. Frequently we are looking for highest value. In such cases, generally index maintaining ordered data. Least value is at the beginning of index, highest value is at the end of the index. So if you create a normal index and if you are looking for highest value, then what is happening? The highest value is available at the ending. The total index values has to be scanned. So how can I reduce it? If you create an index reversely, means if you create reverse index on a column, then it will start the search from rightmost node to leftmost node. Means right side tree will be traversed. Okay, then it finds out the highest value as much as fast. So why should I specify rightmost node, leftmost node? Indexes are developed by using the concept of binary tree, B tree. Binary tree concept. In C, C++ you have a trees, C language. Okay, binary tree or balanced tree. Every node in that tree is having 2 subnodes. Remember, okay, generally within the tree, the index will be searching from leftmost node to rightmost node. If you are creating a reverse key index, then it will be traversed from right to leftmost. Yeah. So generally, let me generalize this. This is created if you are requesting about highest values. If you are looking for highest values, then it is better to create reverse key index. How to create a reverse index? Here I am creating reverse index on sales table and on the column sales amount. Yeah. Example, create index idx underscore, you are creating on sales amount column. Okay. On what is the table name? Sales. What is the column name? Sales amount. And what kind of index it is? It is not normal index. I want to create reverse index. At last specify the keyword reverse. Then the index will be created as reverse key index. Yeah. Next type of index is function based index. Function based index. Let me explain it. It's very simple answer. See, I have a table EMP. Salaries column is there. I want to display employee ID, salary, and some percent of salary is as commission. Suppose 10% of salary as commission. So for that you will write a query like this generally. So how to write a query? Select employee ID and salary and also 10% of salary, 0.10 into salary. That should be as a commission or something, TA, DA, whatever it is, from EMP. What will happen? First, employee ID, salary should be loaded into temporary memory. That temporary memory is called as cursor area. In PLSQL, we will discuss about what is cursor. So in the cursor area, the control has to calculate 10% of each salary. The control has to calculate 10% of each salary and the final result will be displayed to client. This is the general process. Frequently you are doing same action. Then what will happen? What will happen? Every time it has to perform the same kind of operations on the column. 10% of salary it has to calculate. It will take some time for calculations. If I maintain already calculated values in the index, then directly your value will be fetched from, your value will be searched based on index. Yeah. So how do I create it? So this is the simple answer, but technically how can I create a function based index? Within the index definition, all these things are called as index definitions. Within the index definition, if you use any function on the column, if you use any calculation on the column, that is called as function based index. Here example, create index and index name is IDX and on salary some calculations, whatever it is, IDX underscore salary 1 on EMP table, and I am creating index on salary, comma 10% of salary, 0.10 into sal, and also I am fetching the data from ename column also, and the values should be displayed, employee names should be displayed like beginning character capital, remaining characters are small. So I am using the function init cap of ename. So this is called as function based index. In the index definition you are having calculation and functions also. Anything you can use. Now next type of index is the most important index, bitmap index. Bitmap index. What is bitmap index? Most important. Bits. What are the bits we know? Generally bits are 0, 1. Okay. What is meant by bitmap index? You have a table. One column is there. 10,000 records are there. But within the column you are having only two different values for each record. See, customer details. In the customer details, gender column is there. So the gender value, maybe it is male or female. 10,000 customers or 100,000 customers. In any case, what is the value of gender column? Either male or female. So many number of records, but all the records, for all the records there exist only less number of values, very less number of values in a column, less number of distinct values in a column, like male and female, employee status, active, inactive. Okay, in such case, create bitmap index on gender column. Then 0 is mapped with one type of values. Or suppose male is mapped with 0. All males are mapping with 0. All females are mapping with 1. Okay, yeah. How to create that bitmap index? Create bitmap, it's a single word, index, and idx underscore gender on, what is the table name? Customers table. In the customers table, what is the column name? Gender column. This is called as bitmap index. And what is B-tree index? If anybody can ask you, what is B-tree index? There is no separate B-tree index. Generally, all indexes created based on B-tree concept only. Internally, index searching is done based on trees concept. Like start with root node, go to left node, and from left to right it has to be traversed. And again go to left node, and then it has to traverse it from left to right. This is the general searching criteria of index. Okay, every index is a B-tree index, remember. So these are the general types of indexes. Okay,